Okay, so this is just a little update. Try not to make this such a brutally long video. Sorry about that last one, guys. Sometimes I get yabbering way too much. Anyway, this is what I was actually trying to do the first time. Alright, now I'm working with a fully charged battery because it's probably going to be closer to what, what will actually happen. Now, the purpose of this circuit is to give some chickens just enough light in a chicken house so that they're not distraught and stressed out in the absolute darkness. Now the other thing is we've been experimenting with LEDs, and you can use red LEDs, but warm white and white LEDs tend to stress the chickens out, and it brings out little red spots that are on their skin, and then they'll go furious and peck the crap out of peck the shit out of each other, and it doesn't work out too good. Although I saw a video on the internet with red LEDs works pretty good. Anyway, this is closer to what I was trying to do yesterday. Now you can see I'm working with a higher battery voltage, 12.8, and my current draw is just over 100 milliamps for the illumination. So this is the illumination that the chickens would get. Now, after much experimentation with the number of winds, I now have about 5 winds on my DC choke, same inductor on the base. But see how this works here now is and this took me getting down to the 100 ohm mark. Like I tried 1200 ohms, I tried 1600 ohms, none of it worked. And what I'm trying to do is I'm trying to get close to the threshold before the bulb will really conduct. Okay, and so when I add, in this particular case it's 1100 ohms, 1200 ohms wouldn't quite do it, and then you get into like 900 ohms, it goes too far. So when I add that baseline, this of course would be on switch, you can see what happens. I come up now to 700 milliamps, alright, and I get a really nice brightness out of that with high voltage alone and not a whole bunch of conduction. Now if I could find and actually I have, but I've never got them to run efficiently, but if I could find a 2 watt CFL, I wouldn't even bother with this. So if you know of one, let me know. The whole point is that I'm trying to, now this would be a second mode, okay? This is when you walk into the chicken coop and you want to have some light for yourself. So when you walk out the door, you hit the switch, it goes back down to that, okay? In which case we have, about 110 milliamps coming off that. And then the bright mode, okay? Alright, it takes us up to 6, 7. Now you'll find that for every bulb there's a conduction point. Okay, so for example, if I take this 100 ohm resistor out of here, alright, this is the difference. Now I'm working on 1000. See how that goes? See how it starts to rage? And then it starts really pushing current through the bulb and gets horribly inefficient, and will probably, keep climbing up to 3, 4, 5 amps or whatever. So without having a heating element, I've determined with this particular circuit anyways, that's about as bright as I can get. Now it's kind of interesting too what happens to this wave. I'm quite surprised on it. Hope you can see it. Is it's actually broken up. You see that? Let's see if I can get that zoomed a little bit more. I'll just zoom this in. And that I don't understand. Doesn't look particularly good to me. I don't really quite understand what's going on there. See, there's my spike. Okay. And that's high mode. And then there's my spike is available. I'm trying to just use that spike up. You can see even just touching this, it acts like an antenna. Okay, so you know the difference would be, let's say that was 1100 ohms. Now if I put on 1250 ohms, this is more like what I had before. So that's, oh, it is pushing me past that threshold on this one. Okay, so between 11 and 1250, I kind of like that actually. 1250 works pretty good. I've just been experimenting with different, see, because now I've got different number of turns on my inductor too. Same inductor on the base though. But that's running 660 milliamps at 12.6 volts. And you can see it's broken into quite the complex wave. That I don't quite even, oh there we go, that makes more sense. Well, I don't know. It's really, I find that strange. I don't really quite understand how I should be looking at this. See, to me that waveform right there makes sense. And then I get into this. If you can explain to me why it looks like two waves, that would be cool, because I don't quite understand why it would look like that. Anyway, more musings in the CFL circuit on the joule ringer. Thanks for watching.